Hi, this is Chris Riley. Today I'm going to show you some quick and easy ways for generating G-code that you can run on a CNC mill using just a raster image as the source. Now, this is a great technique for beginners since it doesn't involve any CAD modeling at all. All we have to do is generate a two-dimensional raster image, and the grayscales in the image will get mapped into a three-dimensional form that we can run on our CNC mill. So I'm using a version of Linux today called Enhanced Machine Controller, and that's a special distribution of Linux that has some software in it to run CNC mills. You can download it for free at linuxcnc.org. The other piece of software I'll be using is the GNU image manipulation program. That's a raster editing program, kind of similar to Photoshop. So let's get started in GIMP and create our raster image. Okay, I'll start out by creating a new file. So I'll go to File, New, and I'll make my image 400 by 400 pixels. So the basic technique here in GIMP is to create different grayscale values in our image, and those will get mapped to different depths of cut when we run it on our CNC mill. So a great tool to use is the blend tool, and we can use that to create smooth gradients. So this is a really quick and easy way to get started creating your grayscale image. I'm just going to flip the foreground and background colors here. So I want white in the foreground and black in the background. I want to set the shape of my gradient to be a square. So on my canvas here, I'll just click in the middle and drag out to the edge. And you can see I have this gradient here. And you can already see, just looking at the grayscales, it forms this kind of pyramid shape. And that's actually going to translate into a three-dimensional pyramid when we translate through EMC to get our G-code. So you can really spend as much time on this as you want and make this as complex as you want. I'm just going to do something quick for a demo. One additional thing I'll do is change this gradient type from foreground to background to foreground to transparent. And that'll let me just do a couple little overlays on top of the pattern I already created. So I can do some radials, and those will be sort of hemisphere shapes, and a couple more squares for a smaller pyramid. Okay, that's looking pretty good. So I'll just save this out as a PNG. So File, Save As, and I'll save to my desktop. As a PNG file. And I'll just use the defaults when I go to save. Okay, I'll hide GIMP. And now I'll open up EMC. So again, this special distribution of Linux has the Enhanced Machine Controller 2 program already installed on it. And on my desktop here, I have a shortcut to the configuration for my CNC mill. Now, I'm not actually hooked up to the mill at the moment, so EMC is going to give me these warnings. I'll just exit out of those. A couple things I'll do to get this ready to sort of simulate my G-code once I run it is I'll toggle off the emergency stop, and then I'll toggle on machine power, and I'll manually home all the axes. Again, we're just kind of tricking EMC into thinking that there's an actual machine attached when there's not. Now I'll just go ahead and open my raster file from the desktop. And I'll get this image to G-code dialog. And here I see a bunch of different options that I can set to tell EMC how to interpret my grayscale image. So the first option is for units. So I'm working in inches. You could set this to millimeters though if that's what you're working in. I want to leave invert image unchecked. So by default, EMC will treat blacks in the image as deeper cuts, whites in the image as higher points in the three-dimensional form. Normalize image, this is a good feature to use. This will automatically map the darkest pixels in your image to black and the lightest pixels in your image to white. So that gives you a better range of cutting depths. We could add a bleed with extend image border, so we can add either black or white pixels around the edge. That can help prevent details from getting cut off around the edges of your image. The tolerance can help to smooth out lines of pixels that are, more or less in a straight line. By increasing tolerance, we can actually make the cuts run faster. but we may lose some of the detail that's embedded in our raster image. So I'll just leave that at 0.001. Pixel size, this can really be whatever you want. Now I know that the piece of stock that I'd like to generate this G code for is 2.5 inches by 2.5 inches. So to figure out the pixel size, I'll just divide my stock size, so 2.5, by the pixel dimension, which is 400. So 2.5 inches over 400 pixels gives me 0.006 inches per pixel. Feed rate, plunge feed, and spindle speed, these will depend on the material that you're using and also on the machine that you're going to be running the file on. So this is going to be pretty good for my DIY LIL CNC and a softer material like foam. But again, that might be different for you. Scan pattern, this is basically going to say go back and forth, go front to back, or do patterns of both. So right now I'll just do rows. So we'll just do a back and forth scan over the raster image. Scan direction, alternating is going to be the fastest. Now again, this might vary depending on the material that you're using. So if you do need to worry about tear out, for example, with a hardwood or something like that, you might want to take into consideration the direction of rotation of your cutting tool. For now, I'm just going to leave this on alternating though, and that'll give us a faster run. So the overall depth, I'm going to set this to 0.5 inches. So from the whitest pixel to the darkest pixel, that's a range of 0.5 inches high. And step over 8 pixels should be fine. So that's the amount of overlap in between passes that the machine's going to make. And my tool diameter is 0.125 inches. So I'm using an 1/8 of an inch bit. I'm using a ball end. Again, this is going to depend on the type of material and the machine that you're running this on. Safety height, also referred to as the clearance plane, that's the height above the material that the machine will travel when it's not engaged with the material. So as it's moving from one part of the cut to the next, this is how high above the material it will run. I also have some options down here for roughing, so we can have EMC automatically generate G-code to remove larger parts of negative space out of the stock. Again, I'm using a soft material here, so I'm not going to do any roughing passes, but if you're using something harder, this is a really useful feature. All right, so let's go ahead and hit OK and generate our G-code. Okay, and I can see here in my preview, I have a pretty good approximation for the actual three-dimensional form that was made from my grayscale image. And if I go ahead and hit play here, I'll get a nice preview of how this is actually going to run on the machine. That looks pretty good, so you can see I'm doing my alternating pattern, so I'm going back and forth in both directions. And this looks pretty good to me, so I'm going to go ahead and stop this. And now to actually save out the G-code, I'll just go to the File menu, save as G-code. And I'll save this out as an NGC file. Now if I take a look on the desktop, I'll see that NGC file. And really this is just a text file with all my lines of G-code with all the points that the machine needs to travel in. And this is a pretty versatile file, so I could run this on a range of different CNC machines. Okay, so that's a quick and easy technique for generating G-code from a raster image. Check back for more tutorials on DIYLILCNC.org coming soon.